Hi, good evening. I'm Dr. Philip Macmillan, and I am now going to simply explain to you why, based on our research, severe COVID 19 is an autoimmune disease. If you don't get this, nothing that I explain beyond this will make any sense. And I'm doing this really critically because I'm preparing for STORM, spike triggered autoimmune response mechanism. And if you don't understand the basics of this autoimmune question, it won't make any sense. So you have to just follow along with me as I quickly take you through the points. Just a reminder that if you haven't as yet registered for it, please look in the link below and you'll be able to see a link to register for the webinar. It's coming up in just a couple of days and there are tickets available. Just make sure you register. The other thing that I'd like to ask you to do, as usual, is please make sure that you sign up for our newsletter because you will also get, with regards to the newsletter, a free ebook looking at nitric oxide. And so make sure you sign up for that. It's right there. And critically, make sure you click on the subscribe button, which, if you're on YouTube, should be right at the bottom corner of the screen right here. So I'm just going to quickly take you through a few points about this. So I've put a few slides together because I thought that it was very important. I cannot express how much how critical this is. This is what we said from 2020. And what I'll be making reference to is a very important paper. They did the research that we wanted to do. We didn't have the funding at the time. So autoantibodies to ACE2 and immune molecules are associated with severe COVID-19 disease severity. This was published in March 2024. So I'll be taking you through a few of the slides or the images from this paper because this is a critical piece of the understanding. As I said, the STORM, this spike triggered autoimmune response mechanism, doesn't make any sense without an understanding of this fundamental point around autoimmunity. So let me just take you through a few slides so that you see where I'm coming from. Um, First things first, as usual, let's start with the basics. I'm just getting a few things here. We're starting with the basics, which is just really that you have to understand the way how the spike protein works on the virus. So this here is effectively what you would see. This is the virus, SARS-CoV-2. This is the viral spike protein blown up. So the blue parts on the virus represent the spike protein. There are usually about 25 of these on each viral particle. Any one of them, if it attaches and the receptor binding domain up here for ACE2 is at the top, any one of them can allow it to enter a cell and then replicate and make thousands new viral particles. That's how the system works. Um, what you have to note is that this spike protein doesn't just bind to ACE2. Okay, so I'm going to be showing you the image around ACE2, and this is where we started. We had said that when ACE2, free ACE2, binds to the receptor binding domain of the spike protein and it gets chewed up by the immune system, it can't differentiate the spike protein from this ACE2. And so it would make antibodies to both. That was the simple fundamental starting point. But what you must remember in this image is that there are a number of other proteins, and I've only highlighted three of them here, but there are a number of other proteins that bind to the viral spike protein in the same way as ACE2. Now, that is very, very important because if you have the immune system not being able to differentiate, and this doesn't happen in everybody, but if you have this occurring in a cohort of people, you can then end up with a cytokine storm. That's where, remember, it's not the virus that killed people in severe disease. Really simple but important point. Just think of how many people had the virus. They didn't all die. Think of how many little babies had the virus. They definitely didn't die. And so, what you know is that the virus was not causing the severe disease. It was the immune response to the virus, kind of like what can happen with dengue hemorrhagic fever when you get a second viral, a different variant of the dengue. It's the immune system that causes the dengue hemorrhagic fever. That's a useful example to remember. So again, I'll show you how it would look. These are a number of other other proteins binding to the spike protein if they're free floating. The critical one we had focused on here was ACE2. Now, I think when I reflect on it, I think that even though they ignored what we had said, because we were saying this from April 2020 about autoimmunity and ACE2, and I couldn't understand why nobody was listening because it was such a simple question. But there's something important that they did with the mRNA vaccine, which didn't occur with the AstraZeneca or Johnson and Johnson vaccine. And I think it's part of the reason why we see different kinds of issues with the different vaccine platforms. And it was that when we compare the AstraZeneca to the mRNA or Pfizer spike protein, look at this carefully. What they did, so this is the spike protein that had been replicated by AstraZeneca. So they just replicated the spike protein when they and with the DNA viral vectors. In the context of the Pfizer and Moderna, they added two proline amino acids in this region, in the receptor binding domain. Now, they said it was to stabilize the spike protein. But my suspicion is that they did that to minimize the risk of the free ACE2 binding to the receptor binding domain. If they did it because of that, it would suggest that they also took this autoimmune question in seriously. And to me, it's a really, really obvious question. And it differentiates why I think we see different kinds of complications between the different platforms. You get much more clotting issues with the AstraZeneca, but you have far more myocarditis with the Pfizer. And I think actually, when they stabilize the spike protein, they make it harder for the immune system to break it down. I think that that's just my theory as to why this causes more myocarditis than the AstraZeneca and why this will cause more autoimmunity with ACE2 than the Pfizer. But that's a very important point. They did aim to change the way how the ACE2 could bind to that spike protein. So now, when we go to the paper, that paper that I wish we could have done, they looked at autoantibodies. And remember, what they were looking at, your normal proteins don't, your immune system knows not to make an immune response against a normal protein. Because if it does that, it will not only damage the proteins, but it will damage the cells that have the protein. And so there's a very sophisticated balance in the immune system where it tries to block this from occurring. Really critical point. So when they did the research that, as I said, I wish we could have done, they were looking specifically for autoantibodies to ACE2. Because in my view, autoantibodies to ACE2 don't exist that often. They really are quite rare. There are very few diseases that are associated with them. So they're not a common factor. And based on the way how the severe disease was presenting, it all seemed to occur in people who had elevated levels of free ACE2. So our question was simple. If you find autoantibodies to ACE2, that strongly points to the fact that it is an autoimmune disease. And so what they found in that paper is this. So you can see here that they are looking at different kinds of antibodies, IgG here, IgA, and IgM. IgM is the early one, IgA is usually mucosal, and IgG is long acting. Healthy, mild, severe. Now, when you look at it, in every situation, the severe was significantly above what was occurring with regards to mild and healthy. You can see here the IgM very elevated, IgA very elevated, IgG very elevated. The fact that this occurred with ACE2, really uncommon for autoantibodies to exist with that, suggests very strongly that ACE2 is central in that autoimmune response that leads to a cytokine storm. So our research suggested that ACE2 is the trigger, critical bit of the puzzle, but it leads to multiple other problems in terms of autoimmunity. But before I move on to the next point, I just want to highlight that when they looked at the Pfizer vaccine, because they then looked for it, can you believe it? In 2024, we finally get a paper published looking for what I thought should have been the critical question. Luckily, we don't see any significant change between baseline and vaccinated for the Pfizer one. My suspicion is that if we did this for AstraZeneca, we would see a difference. But because of the fact that the Pfizer, as I said, the proline residues impacted on the ability of ACE2 to bind, we don't see any significant response. But remember this, they only adjusted for ACE2, but there are a whole bunch of other proteins that bind at different locations on the spike protein. Now, when we look at the cytokine profile, autoantibodies to cytokines, and cytokines occur in severe, in any kind of infection or inflammatory process where the body is trying, the immune system is getting targeted or is targeting something. What we find here in this same paper is that you can find autoantibodies to these cytokines. They're looked at interleukin 4, interleukin 17, interferons. They looked at the GM-CSF, interleukin 6. And this here would be your baseline here. And they're looking at IgG, IgA, IgM. And you can see for most of them, they're elevated. And that means that there was broad autoimmune responses, including targeting cytokines. This is why I said that this is behaving broadly like an autoimmune disease. And the final slide I wanted to show you here is this one, the difference between severe and healthy. And this is again looking at the autoantibodies to IgG and IgA, and these are the list down here are all the different points along the peptides that they're looking at. And all you have to look at is the map. In a healthy person, there are a few scatterings of red. But in severe COVID-19, you have all of these red areas of IgG suggesting autoantibodies, autoimmune responses. Same here, even more so with IgA autoantibodies compared here to the healthy. And so everything here is pointing to the fact that severe COVID-19 is a significant autoimmune response to the viral infection. That's the critical piece of the puzzle. So when I start talking about storm, spike triggered autoimmune response mechanism, what I'm speaking about is that this autoimmune priming has occurred, and it can occur both from infection and from vaccination. Therefore, on re-exposure, my suspicion is that you are going to then get this kind of pattern occurring where we have much more autoantibodies presenting, and depending on the characteristics of the patient will determine where their storm is affecting. So this is what I'll be focusing on in the next few days. And if you've missed this, you will see a link, hopefully, to the full presentation. But again, I remind you, because I'd like the questions, join me. New COVID storm, recognize it or risk the consequences. Join me in a few days, or if you don't see it, then look at the link and you'll be able to follow it and understand it more. This is important stuff, but this important basic about autoimmunity is critical for us all to understand what the next phase of the disease is likely to be.